Hi, my name is Braden Minnie.
Hello, my name is Jerome White.
Hello, I'm Shelley Clark.
So today we'll be talking about engineered design. So the engineered design process is a great tool that is suited to cross-disciplinary instruction in STEM content areas. The engineered design process is a seven-step process with a focus on problem solving and developing the skills in students to analyze the data in front of them to come up with an answer to a specific problem or question. This suits cross-disciplinary instruction in STEM, as when students are solving complex problems, they need to utilize many different banks of knowledge to come up with the answer to the question at hand. For example, when students are completing scientific projects in a lab setting that requires some type of testing or research, they will need to utilize both their scientific skills and their mathematical skills to answer the problem. When they are testing, they are collecting quantitative data that requires the ability to use their scientific skills to collect the data, and they're using their mathematical knowledge to interpret what that data actually means. Many questions and problems that are presented and solved using the engineered design process are not linear problems. They require unique approaches and solutions, students thinking outside of the box. When combining these type of complex problems with a cross-disciplinary teaching approach, teachers are setting their students up for success to be better thinkers and better problem solvers.
Hello, I'm going to talk about ongoing PLC support and evaluation. Following the professional development, our PLC will continue to support Nevada STEM teachers by providing ongoing collaboration, shared instruction, and resources, and structured opportunities for reflection focused on engineering design process. Teachers will participate in follow-up PLC meetings to share lesson plans aligned with Nevada standards, review student work, and analyze assessment data related to engineer-based instruction. These collaborations discussions will help teachers identify effective strategies, address challenges, and refine instructional practices. To evaluate effectiveness, the PLC will use formative assessment data, the student performance outcomes, and engagement indicators to measure impact. Peer observation and instructional walkthrough will provide additional feedback to support consistent implementation across STEM content areas. Research indicates that sustained professional learning communities support instructional improvement through collaborative inquiries and data-driven discussion making. By maintaining ongoing PLC supports, teachers will be able to better be equipped to implement the engineering design process with improvement to student learning outcomes across Nevada classrooms.
I'm going to be talking to you about implementing the engineering design process into our future professional practices. Implementing engineer design process takes cooperation among a department and grade level. It cannot be a standalone process. We need to work with our departments and grade levels to discuss the benefits of the process, especially how it helps students become more critical thinkers and learn to solve real world problems by becoming more analytical and innovative in finding solutions. Focusing on growth mindset and learning from mistakes, errors, missteps, and perceived failures are key components. Students will need to have access to a design notebook so they can refer to the process continually, as well as having the process posted in the classroom. Their notebooks are used to notate the steps for each project and serve as the blueprints for the process. Implementing the engineering design process cannot be done in name only. It must be fully integrated into each part of the curriculum, just as STEM becomes a partnership across disciplines. Students need to realize the benefit of having a defined plan as they tackle any problem, so they can determine the ask, conduct any research, plan, create a model, execute the model, and revise as necessary, and share their results. This can be done in science, social studies, math, computer science, art, and even in English classes. A project entails many components, and when we are lesson planning and developing instructional units, as we work with a cross-disciplinary focus, we can weave STEM and the engineering design process into our plans so students can reap the benefits of a well-defined planning process. Thank you.